This is a quick video to explain how to convert logarithmic equations to exponential equations. If you need to go back the other way, check out the other video in my YouTube channel. So first I want to take this first example and talk about some terminology with this. For logarithms, the number that's below the line as a subscript is called the base. The number that is beside that is going to be called the argument. And this 2 out here, sometimes people just call this the answer, but also sometimes we can, especially with this purpose, we can also think of this as the exponent. Now this is not an exponent in this logarithmic form, but when we go and convert it to exponential form, then it will be. Okay, so how are we going to write this? If I want to change this logarithmic equation to an exponential equation, first, I'm not going to write the logarithm. Second, I'm going to write the base. I'm going to raise it to that answer or the exponent there. And this will be equal to the argument. So let's see how this converts for this logarithmic equation. So if I wanted to write the base, in this case it would be 3. My exponent would be 2. And this is going to be equal to my argument of 9. Now, if all of these things, the base, the argument, and the answer or the exponent are numbers, they're not variables, then you could actually just check to make sure you did this correctly. 3 squared, 3 times 3 gives me 9. So this is a true statement, and if I've done this correctly, it should be a true statement. Provided that the problem they gave you works out that way, of course. All right, let's do the other one. So identifying these the parts for this logarithmic equation, the 5 is going to be the base. The 25 is the argument. And then our x is, in this case, going to be our answer or our exponent. Okay, so it might be the answer to the logarithm, but when we change it, it becomes the exponent. So when we convert this, we're going to have a base of 5. We're going to have an exponent of x, and this is going to equal 25. So part of the reason that we want to be able to convert logarithmic equations to exponential equations and change that form is that many times we can solve and figure out the variable by doing that. And the reverse is also true depending on the situation. But you can easily see here, if I needed to solve this, and in this case I don't need to because it just asked me to convert it, but if I needed to solve this, I would just say, how many times do I need to multiply 5 together to get 25? And so my exponent there would be 2, and my x value would be 2. So you can see why this applies to these concepts. Let's do the same thing with this last one. Let's do it this time without identifying anything. So we're starting off with our base. We're going to then raise it to the 3rd power. And this is going to equal the 8. So you can see I kind of did a backward C motion. If you've seen the other video with converting exponential to logarithmic, it's the same motion. So you're doing the same thing converting back and forth. You're starting with the base always, going around. That's going to be your exponent in this case, and then it's going to equal to that 8. Okay, and we could certainly sit here and try to figure out what x is. What would I need raised to the 3rd power? It would be 2. But again, this problem is just asking us to convert, and so that's it.